Hi, everybody. My name is Emmanuel. I'm the CEO of a company called Sematic. We have a booth out there, and we are about to launch a new product called Airtrain. This talk is not necessarily about Airtrain. It's mostly about trends that I've noticed in the Gen AI space and what's the future for AI models. So I call this talk oracles and worker bees, and this will become apparent why I'm using those terms. So if we look on this plot at on the x-axis, we have the time, and on the y-axis, we have log 10 of number of parameters in large language models that came out. So as you can see, for a long time, there's just a few models coming out, and they were steadily increasing. And then ChatGPT was released in November 22, and then since then there's been an explosion of very large models with more and more parameters. Even GPT-4 up there. We don't know exactly how many parameters are in there, but probably around 1 trillion parameter. And the scale on the y-axis here is log 10. So you can see how this exponentially gets bigger and bigger. And so this is fantastic. You know, LLMs perform great. We all know that. We all use them every day. But they remain wild luxuries. And I use those words carefully. Why do I say wild luxuries? They're wild because they're uncontrollable. We don't know the outputs of those models. We don't know what they're going to return. It's very hard to control them, to know exactly what's going to come out. And wild luxuries because they cost a lot of money to query, cost a lot of money to run. So you have all those issues that come with LLMs. You know, safety, we don't know if they're going to return any toxic outputs. Privacy, we can't really give them some private data because they're usually behind cloud APIs. Unpredictable, they're kind of slow, they cost a lot of money, and so on. So I hope I convinced you that those animals are extremely powerful and interesting, but they're also quite dangerous to use in your day-to-day production in your company. So on the other side, you can see in the industry there's a quest for running models on local machines, so on laptops, on phone even. There's an entire subreddit called Local Llama dedicated to how can I run models on a small machine. So an example is Llama CPP, for example. I'm sure all of you are aware of that. It's a way to run Llama on your local machine, for example, on your M1 MacBook. And this project has been extremely successful. You can see the mission statement at the bottom here. The purpose is to run the Llama model using 4-bit quantization on a MacBook. So as you can see, people are trying to run those large models on small devices because not everybody has access to A100 GPUs. Not everybody can pay for all the OpenAI GPT-4 tokens and so on. So you even have people that are trying to run LLMs on CPUs by using some smart combination of pruning the graph and quantization. They're trying to run models on smaller and smaller devices. So that's great. And on the other side, so on one side, people are trying to run those large language models on small machine. On the other side, there is a lot of evidence to show that small fine-tuned models can compete with large models in certain circumstances. This is the first evidence of this trend. This is a paper by Microsoft, I think it was in April last year or this year, called Textbooks Are All You Need. Essentially, they trained a fairly small model, so 1.5 billion parameter, and they fine-tuned it on a very high-quality data set. So they scraped textbook quality data of the internet, and they added synthetic data generated by GPT 3.5. And what is the result of this? Well, the result is that the performance of this model is for code generation. So the result is that the results are comparable or beat all the other models, not GPT-4. GPT-4 is still the top of the class there. But you can see with only 1.3 billion parameter, this performs much better on human eval than other models with much more parameters. So as you can see, a small model with very high quality data sets for fine-tuning can lead to equivalent performance. See, it beats all other models, small and large, except GPT-4. This is the second piece of evidence to make this point. There's a paper called Tiny Stories where they generated a synthetic data set using GPT-4. So it's a data set of very simple stories using only words that can be understood by kids of 3 or 4-year-old. So again, a very tiny model in this case, about 10 million parameters, so very small. Synthetic data sets generated by GPT 3.5 and GPT-4. And the results are quite interesting. So maybe you can't quite see here, but for reference here, you have a fairly large model here, GPT-2, 1.5 billion, which today would be considered small, but compared to those sub 100 million parameter models, it's pretty big. And the color essentially grades the quality of the outputs. You have a prompt at the beginning here, and then the models are asked to complete the story. And the model that performs the best is a 4-layer model with 33 million parameter, and that beats GPT-2 that have 1.5 billion parameter. Once again, here the pattern is small model, a synthetic data set, so very high quality, much higher quality than what you would get by simply scraping the internet, and that beats larger models. So I hope I was able to convince you that small models are able to compete with large models. In addition to that, a new trend is to use those very large models to generate data sets. So when you generate a data set with a large model, the quality is much better than what you would get otherwise. This is a very cursory example that I did last night, where I asked GPT-4 to generate a data set. So 100 simple stories about everyday life. Each story should have no more than 4 sentences. Story should use one of 3 language modes: casual, common, distinguished, and the output should have the following format, so a JSON payload with the mode and the story. And as you can see, the output is very high quality here. For example, the first one, casual mode: yo, so Jake totally missed the bus this morning. Obviously, this is casual. And then common, Emma found an old photograph in the inner attic. And last example, distinguished language: upon the stroke of dawn, Sir Edward embarked on a solitary walk. So this was all generated by GPT-4, and so you can generate hundreds and hundreds of those and create a data set. And it's been shown that you can fine-tune models with very small data sets. Sometimes a few hundred examples are sufficient to fine-tune those models. So you can use those very large models to generate data set to fine-tune your smaller models. So the point I'm trying to make here is that what I call oracle models, those very large, very smart models that are very hard to run and very expensive, are going to be few and far between. There's going to be a handful of those existing out there. So you can think of the Llama 2s, the Falcons, Claude 2, GPT-4, and so on. And these are going to be used as a repository of knowledge. They will have the entire corpus of data that's available on the internet. They will know everything about world history, mathematics, every discipline that you can think of, be much more creative, much more sensible. And then you will have an army of very small models, so I call them worker bee models, that will be used for very specific tasks. So for example, if you're looking to do JSON generation, your model doesn't need to know about ancient Rome. It doesn't need to know about how to optimize a accounting spreadsheet, doesn't need to know anything about all those different topics. It needs to know how to format JSON correctly. If you're looking to do, for example, travel planning, you need to know about geography and travel, maybe a bit history, but you don't necessarily need to know about math, for example. So there's going to be a huge fleet of smaller models that have been fine-tuned using data that was generated by those oracle models here at the top. And those models here will be much cheaper to run. They will run on your local machine, much easier to debug, much cheaper to run, easier to keep guardrails around and control the output, much more manageable in production. So in the next few years, what you will see is that even though those models will keep on coming out and existing in the wild, these are the actual ones that we will be using in production for very specific tasks. So this is what I call oracle models and worker bee models. So just to summarize, future of AI models, a handful of very large oracle models that will know everything, very, very, very hard to run, and a large amount of smaller worker bees that will be doing the actual work in your production environments. So with Airtrain, we want to be part of this revolution, and we think the next step towards this kind of army of small models is evaluation. Without evaluation, you cannot develop any model. You don't know how to grade the output of your model. And right now, there are no really, the only sort of versatile technique to evaluate model is to use another model, for example, an oracle model like GPT-4 to grade the outputs of your smaller models. So you can use those large models to both generate the input data sets and also grade the outputs. It's just like a teacher. The teacher generates the textbook and also grades the papers. So very much like that. So Airtrain is a no-code platform for evaluation. And so you can check it out at this QR code here and reach out to us. Come see us at the Sematic booth if you're interested to talk. Thank you so much.